Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going over section 2.6, solving absolute value equations. Now, the first thing we need to do is know our definitions. Because in mathematics, if you don't know what you're talking about, it's really hard to figure out what the answer is, or at least what the correct one is. So we're going to start out with, what is an absolute value? An absolute value is the distance a number lies from 0. And if you're really mathematically inclined, you can also say that the absolute value of a number is equal to the square root of that number squared. But that's like a really mathy, geeky version. I think the one that we really want to use is this one right here, that the absolute value is the distance that a number lies from 0. So for an example, let's say we have the absolute value of -4. Notice that these straight brackets let us know that, hey, that's an absolute value. And you're like, oh, well, all right, so what do we do with it? Well, first, we would look at the definition and say it's the distance a number lies from 0. Well, here's 0, here's -1, -2, -3, -4. How far is that from 0? Well, that's 1, 2, 3, 4 spaces from 0. So the absolute value of -4 would be a +4. All right. Now, what about the absolute value of, like, 3? Okay, well, let's look at the absolute value of 3. Well, that lies right there. Let's see how far it is from 0. 1, 2, 3. So the absolute value of 3 is 3. What does this mean in what I like to call layman's terms? What does this really mean in an English that I can understand, not this mathanese stuff? Well, what this means for me is that absolute values remove negative signs at the end. So if I have the absolute value of 4 minus 8, I don't remove the negative sign right away. I only do that after I've finished all of the operations on the inside. So if I have the absolute value of 4 minus 8, I would begin by doing the operation inside, which is subtracting 8 from 4. Doing that leaves me with -4. Now I take the absolute value of -4, which means that I make the negative sign go poof, and when I do that, I get a +4. Now, what if I had the absolute value of 7 minus 2? Well, again, I would do the interior portion first. I would do 7 minus 2, which is 5. And the absolute value of 5 would remove any negatives, but there aren't any. So I'd be left with +5. So in layman's terms, the absolute value removes the negative sign after all the arithmetic on the inside has been done. Now let's look at an example of having to solve for it. Having to solve for the absolute value of a number. Let's say for a moment that we are told to solve for the absolute value of x when x is equal to 3. And I know what a lot of you are saying. Mr. Neal, x equals 3. And I'm like, well, yeah, it is. Yeah, it is. I can agree with that. But is there anything else? Well, again, definition says that it's the distance from 0. So here's 0. On the right-hand side, we have 1, 2, 3. Okay. And what about on the left? That's -3, right? So if I was to go on a journey starting from 0 and I wanted to go 3 places, I could go to the right 3 places and end up at +3, just like we have in pink here, even though it's more like a purple on your screen. But I could also go to the left 3 spaces. And when I go to the left 3 spaces, I'm at -3. That means I have 2 solutions to my equation. My equation is x equals, or the absolute value of x is equal to 3, and then I've got 2 equations, or 2 solutions. So how am I going to do that using like 2-step equations? Well, the answer is not easy. There are 2 ways of doing it. I'm going to teach you the way that has the least room for error. All right. So let's say for a moment that we are given the absolute value of x plus 2 being equal to 5. And we're told to solve for x. So to do this, I know that the distance from x is going to have a positive version and a negative version. So I split my equation in 2. I have a negative version, which I'm going to put to the left, and I have a positive version, which I'm going to put to the right. In the negative version, I take all the stuff that's inside and make it negative, right? Because if I remember, the absolute value of -4 is equal to +4. So if I take all the stuff on the inside and multiply it by a -1, doesn't that make it positive? Now, if I do the same thing with the positive one, I'm just solving the same equation twice. So for the positive version, don't I just make the brackets go poof? So for these, when you're solving an absolute value equation, you make 2 equations. The first equation, you put a little negative in front of. And note how I put it like in front of this, right? I already isolated my absolute value signs, and I only put the negative in front of what's inside the absolute value signs. And then for the positive version, I just remove the absolute value signs. And then I see what happens. On the left, the negative distributes. So on the next line, on the next line, I would have -x minus 2 is equal to 5. Adding 2 to both sides, I have -x is equal to 7. Multiplying both sides by -1, I get x is equal to -7. But there's more to it than just that. There's going to be not only -7, but there's going to be another number that makes it work. And that's going to be over here. If I subtract 2 from both sides, then I get x is equal to 3. So there are 2 solutions. There are 2 solutions. One solution or no solutions to every absolute value equation. There will always be one of those 3. Can't have 3 solutions, can't have 50 solutions, can't have infinite solutions. You either have 2, 1, or none. Now I know what you're thinking. Mr. O'Neill, there's no way that both of those can work. Well, let's try them, right? Let's try out the absolute value of negative 7 plus 2 and see if that gives us 5. And let's try out the absolute value of positive 3 plus 2 and see if that gives us 5. If both of these give us 5, then obviously they're both solutions. So let's see. Negative 7 plus 2 is negative 5. So I have the absolute value of negative 5. Absolute values make the negative sign go away after I've done everything on the inside. So now I have 5 is equal to 5, and it works. The other one, 3 plus 2 is 5. Remove the absolute values, and it also works. All right, so far so great. Let's do another one that might be interesting. Let's say for a moment that I have the absolute value of x plus 3 plus 4 being equal to 4. Now remember, the only time that I can do the positive and negative version of it is after I've isolated my absolute value. So I got to get my absolute value guy by itself. To do this, I begin by subtracting 4 from both sides. And when I do that, I get the absolute value of x plus 3 is equal to 0. Now I'm going to have a positive version and a negative version. I'm just going to use purple for both. Got a positive version and a negative version. So I'm going to have x plus 3 is equal to 0. So x is equal to negative 3. I'm going to have negative x minus 3 is equal to 0, which means that I'm going to have x equals negative 3. Right, add 3 to both sides, divide by, Aren't these the same number? Shouldn't I have gotten different numbers? Well, no, because we're equal to a special one. When we have an absolute value equal to 0, there's only going to be one solution. If the absolute value of some function of x, or some equation, is equal to 0, then you either have one solution. Actually, I think you only have one solution. You have to have one solution. It's the only one that'll work. Or you can have a weird case where you have no solution, which is another possibility. Okay. Let's move down. Our next piece is another example of something fun. Let's say for a moment that we have 2 minus the absolute value, plus the absolute value of 2x minus 5 is equal to 8. 7. 7. All right, let's try this guy out. Well, first things first, we got to get rid of the 2. All right, so I'm going to subtract 2 from both sides. More like that. 7 plus the absolute value of 2x minus 5 is equal to 2. So here, I would subtract 7 from both sides, and I get the absolute value of 2x minus 5 is equal to 5. And then I have a negative 5. Then I have a positive version and a negative version. So the negative version would be negative 2x minus 5 is equal to negative 5. And the positive would be just 2x minus 5 is equal to negative 5. And let's go ahead and solve these two guys. On the left, negative 2x plus 5 is equal to negative 5. negative 2x is equal to negative 10, x equals 5. On the right-hand side, add 5 to both sides. 2x is equal to 0, so x is equal to 0. All right, so we got two numbers that should work, right? These are our solutions. We solve for them. They have to work, right? We found them. Yay, they should work. Well, let's try them out first. So let's pick up our original equation, if it'll let me, and try it out. Let's try it out twice. And we're going to plug in 5 and 0. So let's plug in 5. 7 plus the absolute value of 2 times 5 minus 5 is equal to 2. Let's see if that works out nicely. Subtract 7 from both sides. Now I have the absolute value of 10 minus 5 being equal to negative 5. So now I have the absolute value of 5 is equal to negative 5. And I get 5 is equal to, wait a second. Can 5 equal negative 5? Can having $5 be the same thing as owing $5? Can being 5 paces to the right be the same thing as being 5 paces to the left? The answer is no. This is what's called an extraneous solution. An extraneous solution is a solution that appears to be true, but really isn't. A solution that appears to be true, but gives a false answer. Let's try it on the other side. See if the other number, 0, is also an extraneous solution. So we've got 7. Oh, let's try it in red, right? We have 7 plus the absolute value of 2 times 0 minus 5 is equal to 2. The absolute value of 0 minus 5 is equal to negative 5. The absolute value of negative 5 is equal to negative 5, and what happened again? We get 5 equals negative 5 for the second time. So what happened? This is also an extraneous solution. Why are we getting extraneous solutions? Why is it that when we plug these numbers in, they don't work? Well, it goes back to the definition. At this point right here, we should have stopped and said no solution, or all solutions are extraneous. Why? Well, remember, the absolute value of a number is how far that number is from 0. Can you ever have a negative distance? When every time you take away the negative sign, every time you take the absolute value of something, you take away the negative sign, can that ever give you a negative output? And that answer is no. It can't. You can never get a negative out of an absolute value. It just doesn't work. So this last piece would be if an absolute value of some function is set equal to a negative number, then all solutions are extraneous, meaning they don't work. If an absolute value, that should be and, not and. If an absolute value of any function out there, if it's an absolute value and it's set equal to a negative number, they're going to be extraneous. You can just stop right there and say, done, extraneous solutions. Keep that in mind as you do your homework.